Alright, welcome, Calculus AB. This is section 5.1, the natural log function differentiation. The essential question is, how can you apply the rules of logarithms to make derivatives easier? Let's begin. So, let's start with some review of what logs are. So, first thing I want to talk about is exponential and logarithmic form. So, exponential form looks like this, a to a b power equals c, while log form looks like log base a of c equals b. These are just rearranged forms of the same equation. And so this is how this works, if you remember. If you want to convert exponential to log, you go log base a of b equals c. So log base a of b equals c. And you want to convert back, you just go the other way. So let's take this example. 3 squared equals 9, right? Well, I can write this in log form. Log base 3 of 2 equals 9. So log base 3 of 2 equals 9. Alright, and I want to convert from log to exponential. I go 2 to the 4th power equals 16. 2 to the 4th power equals 16. And yeah, 2 to the 4th power does equal 16. Alright, other thing, so we have something called the common logarithm. That's when you say log of x, where you have like an invisible base. Well, if it's an invisible base, that defaults to log base 10. So that's like the log button on your calculator. And the log function actually looks like this graph right here. Well, this is the natural log function. So let's talk about the natural log first. Natural log is when you have log base e of x. And you can also write this as ln of x. And e is this special number, 2.718, and it keeps repeating on. Irrational number. We use this a lot in math. And here's what the function looks like. There's a vertical asymptote right here on the y-axis, and so this will keep going down forever, and this keeps increasing and going out forever, and you always cross at this point right here, 1, 0. So that's what natural log looks like. Now if you did the common log, it kind of stretches it differently. So a few other properties of natural logs. The natural log of 1 equals 0. So, and why does that make sense? Well, natural log is log base e of 1, which equals 0. If I converted that to exponential form, you'd get e to the 0 power equals 1. And anything to the 0 power equals 1. So that makes sense. This other property here, this is called the product property, where you take the log or natural log of a times b, and you can break that up to natural log of a plus natural log of b. If you do natural log of a to the n power, this is called the power property. I can take that n and take it outside and write this as n times the natural log of a. And this last one is called the quotient property, where if you take the natural log of a divided by b, it's equal to the natural log of a, which is the top, minus the natural log of b, the denominator. Alright, so we use that sometimes to break up logs. And so when we break it up, we expand them. So I'm going to take this example, natural log of 10 ninths. I can break this up using our quotient property of the natural log of 10 minus the natural log of 9. For this property right here, so natural log of the square root of 3x plus 2, and notice like this is the log of this whole thing. Well, square root, that's equivalent of saying the natural log of 3x plus 2 to the 1/2 power. And I can use the power property, take that 1/2 out, and say it's 1/2 times the natural log of 3x plus 2. And there's the expanded form. Now this next one, this is going to be a combination of quotient and product. So the first thing I'm going to use is quotient. So that's natural log of 6x minus natural log of 5. And I can break that 6x up here right here. That's a product property, so I'm going to break that up into natural log of 6 plus natural log of x minus natural log of 5. There's the most expanded form. Now the last one. Oh, what a mess. Well, just break this apart one at a time. I'm going to break it up into quotient property first. So natural log of, x squared plus 3 squared minus natural log of x times the cube root of x squared plus 1. All right, let's break this up. First thing on this left side, this is power property. I can write this as 2 natural log of x squared plus 3. And that's broken up. Now this one, so this is I'm going to do the power property. And notice this minus, I'm going to keep that. You're going to have to you have to subtract both terms here. So L minus the natural log of x plus natural log of the cube root of x squared plus 1. All right, and you know the cube root, that's just saying is the same thing as saying to the 1/3 power. So I'm going to use my product property, and then I'm also going to distribute this negative sign. I'm going to combine some things. So my most expanded form is the 2 ln of x squared plus 3 minus natural log of x minus 1/3 natural log of x squared plus 1. And that's a mess, but that's how you do that. All right, moving on. Derivatives. Let's actually get to calculus here. This is an important part of your notes. The derivative of a natural log is 1 over x. So the natural log of x is 1 over x. You have to memorize this. So write this really nice and put it in highlights, put it at the top of your notes. Let's do some examples of this. So the derivative of natural log of 2x, remember you have to use chain rule here. So derivative of natural log of something is 1 over that something, 2x, but we have to chain rule times the derivative of that times derivative of 2x is just 2. And certain things cancel right there, those 2's. So your answer is 1 over x. What's neat about this? I could have used my properties to expand this natural log, and I could have expanded this out since it's a product to ln of 2 plus ln of x. And now we're just doing the derivative of ln of 2 plus ln of x. Well, ln of 2 is a constant. That goes to 0. So it's 0, and ln of x is 1 over x. So 0 plus 1 over x is also 1 over x. You can use those properties to simplify. Let's do the next one. So the derivative of x squared plus 1 is going to be 1 over x squared plus 1 times 2x. So maybe clean it up a little. X squared plus 1. All right, moving on. Let's differentiate this one. Okay, so got to find the derivative of this function. And that looks like a mess right there. And you could, and then you differentiate the ln, so it's 1 over this mess, and then chain rule. That's way too much to do. This is one of those where you want to use those properties of logs to expand this first. So what's the first thing? I'm going to do quotient rule. So it's going to be the ln of x times x squared plus 1 squared minus ln of the square root. I'm going to convert that to the 1/2 power, 2x cubed minus 1 to the 1/2 power. Okay, expanding those out, we're going to get, let's see, so you're squaring, oops, this was the wrong part. This is actually squared. So I'm going to use product property here. This expands to the ln of x plus ln of x squared plus 1 squared. And this one, I can use the power property, 1/2 ln of 2x cubed minus 1. This one, again, I can use power property. So my most expanded form is ln of x plus 2 times ln of x squared plus 1 minus 1/2 ln of 2x cubed minus 1. Cool. F of x equals that still. Now I want to differentiate that. So f prime of x, the derivative, well, that's going to equal the derivative of ln of x, which is 1 over x, plus 2 times the derivative of ln of x squared plus 1, so plus 2 times, what's a 1 over x squared plus 1 times the derivative of this, x squared plus 1, because of chain rule, 2x, minus 1/2 derivative of ln of something times 1 over that something, 2x cubed minus 1. And then derivative of this thing, chain rule, derivative of 2x cubed is going to be 6x squared. So here's the derivative. If I clean this up a little bit, it's going to be 1 over x plus 2 times 2x is 4x over x squared plus 1 minus, okay, so this is going to reduce, and it's x squared over 2x cubed minus 1. So there is your answer. So this was an extreme case, obviously, but sometimes you have to use those property of logs to make your life easier. All right, logarithmic differentiation. So sometimes you might get an equation like this where you're like, how do I find the derivative of this? This doesn't follow any of my rules. So especially when you have square roots of things like this. So what we want to do first is we're going to take the natural log of each side because it helps us expand things out. So I'm going to ln both sides, and you can do this. It's legal. So you got the ln of y equals the ln of this mess. Okay, now you're going to take the derivative of both sides. So if you take the derivative of both sides, what's the derivative of ln of y? Well, that's just going to be 1 over y times y prime, the dy dx. And that's going to equal, well, the derivative of this. Well, before we do that, let's expand that ln out. So I'm going to do that work over here. So reminder, you have ln of x minus 2 squared over the square root of x squared plus 1. And let's do quotient rule first. So it's ln of x minus 2 squared minus ln of square root of x squared plus 1. And then it's going to be power rule. So I'm going to say 2 ln of x minus 2 minus 1 half, because square root's 1 half, ln of x squared plus 1. Cool. So now, what's the derivative of this thing? So we can go back there. Your derivative is going to be 2 times 1 over x minus 2. I won't skip steps. I wanted to. Minus 1 half times 1 over this mess, x squared plus 1, times the derivative of x squared plus 1, 2x. Cleaning that up a little bit, these 2's cancel. So I'm going to have 1 over y times y prime equals 2 over x minus 2 minus x over x squared plus 1. Well, what do you have to do? Find the derivative of this. When I say find the derivative, I'm asking to find y prime. So I got to get rid of this. So what do I do to both sides? Multiply by y on both sides. These cancel out with y prime equals this whole mess right here. So y times the quantity 2 over x minus 2 minus x, or x squared plus 1. There you go. All right. And, oh, got some examples. All right. So pause the video. All right, now I'll do them. Use the properties to expand. So doing this really quickly, it's going to be 1 half using the power rule, ln of x to the 5th. And I can use the power rule again and write this as 5 halves ln of x. Next one here, this is using the product rule 3 times, so it's just ln of x plus ln of y plus ln of z. All right. Okay, pause the video and do this on your own. Okay, so we want to express a single quantity. That means just put it all together. So the first thing is this 2. Oh, geez. I don't know if I want to start with that 2. Nah, I'm not going to start with that 2. I'm going to combine all the things inside that 2 first. So notice this is being subtracted and this is being subtracted. This is positive, it's being added. So this turns into one big fraction. It's ln of this x on top times these 2 factors on the bottom. X plus 1 times x minus 1. All right, and so 2 times all that. Now 2 is a power rule. I can bring that to the top, so I can write this as ln of x over x plus 1 times x minus 1 squared. And that's one term. If you notice this is difference of squares, you can also write this as ln of x over x squared minus 1 squared. Either way works. And last one. Pause the video. Okay, let's do this. Derivative of this one is 1 over that something, so x minus 1 times chain rule, so times 1, but that doesn't matter. There's your answer. This one, oh man. So power rule, this is going to be 1/3 times the ln of x minus 1 over x plus 1, which is 1/3 ln of x minus 1 minus, I'll put that in parentheses, 1/3 ln of x plus 1. And you're going to find the derivative of this. So y prime is going to equal 1 over 3 times x minus 1 minus 1 over 3 times x plus 1. That's it. Our video done. Our video is done. Stop recording.